As you've already learned, most visual information enters the primary visual cortex via the LGN. The information from the two LGN is received in the primary visual cortex, combined and then segregated into multiple pathways that project separately to various functional areas of secondary and then association cortex. In this module, we will look at the pathways the visual system takes after leaving the occipital lobe. In addition to that, we will look at two different neuropsychological disorders that are associated with vision. As a quick recap from what we saw earlier, remember that the eye is going to be stimulated with light, impact the LGN, and then it'll swing around over to impact the primary visual cortex, secondary visual cortex, and then it's going to have a ripple effect that is going to make use of what we call association cortex. Once we reach the primary striate cortex and the secondary, basically follows through various specialized areas, eventually reaching what we call the association cortex. This can be thought of as components of two major streams, what we call the dorsal stream, meaning going upward, and then the ventral stream, which would be going down. Please note that the dorsal stream is also known as the pathway for primary visual cortex to the posterior parietal cortex, and that is because this is the parietal lobe, and that's where it's going. This is also known as the where pathway, and the reason why is because this is the pathway that seems to be stimulated and active when we are locating objects and movement direction. So this specializes in visual spatial perception. Where is the object moving? If you're playing baseball and the baseball is coming your way, this particular activation and pathway to go upward in the dorsal stream would allow you to detect the ball and the direction of the ball. This is also known as the pathway for control behavior. That's what we call the dorsal stream, control behavior. And this, again, visualizes and specializes in visually guided behavior. So any damage to the dorsal stream can actually disrupt our visual spatial perception. You may not know where things are. And it can also disrupt visually guided behavior, but not conscious visual perception. So you may not be able to guide yourself specifically through your eyes into that, but you may still be able to perceive in a conscious way what's there. The ventral stream is what's called the what pathway. That is also the pathway that goes from the primary visual cortex to the inferior temporal cortex. This is what's known as the what pathway. And this is what detects visual pattern recognition, such as color, shape, or form. The ventral stream is also known for its ability to perceive consciousness. And so any damage to the ventral stream here can disrupt our conscious visual perception, but not visually guided behavior. For example, patients who perform on a test of visual recognition may actually not do very well because visual recognition tests often require a verbal response. You have to state what you're seeing. And so it requires conscious awareness, and the individual may not be conscious of what they're seeing. But when it is not conscious, the individual may be able to then see. Hence it would be somewhat involuntary. When we look at neuropsychological disorders of vision, we're talking about vision disorders due to damage to the brain or some type of deficit in the brain. The eyes, the retina would be intact perhaps, but the problem is there. Prosopagnosia is one of those neuropsychological disorders I'd like us to focus on, and it basically is a visual agnosia, which is agnosia is to not know, failure of recognition, of faces. Prosopagnosics are individuals who have problem recognizing whose face they're looking at, even that of family members and loved ones. With a report seen instead of a phase that would have a pattern that's recognizable, they would report seeing a jumble of individual facial parts that are never fused into an easy to recognize whole. So these individuals, rather than again seeing the nose consistently aligned with the eyes and the mouth, they would just see a chaotic image. The majority of individuals that suffer from this disorder do not just have problems with recognizing faces. In fact, they sometimes have difficulty recognizing their pets. This was actually discovered when a farmer who suffered from prosopagnosia also lost his ability to recognize particular cows when he lost his ability to recognize faces. Now, you may say, well, how do you tell a cow from another? If you have pets or if you've worked in a farm, you'd be able to recognize your pets and your own. And so this individual, in addition to not recognizing faces, had difficulty recognizing cows. It was just different patterns and very, very distorted images. In addition to prosopagnosics, please note that visual agnosias are often specific to a specific aspect of visual input. So we could have like movement agnosia, object agnosia, or color agnosia. These are difficulties in recognizing movement, object, and color respectively. It is presumed that each specific visual agnosia results from damage to an area of secondary visual cortex that would mediate or be responsible for the recognition of that particular attribute or shape. What we find about the brain pathology of people who suffer from prosopagnosia is that it is associated again with damage to the ventral stream between the occipital and temporal lobes. This is also known as what we call as the fusiform face area. And this is basically an area of our brain that's selectively activated by human faces. There have been studies through the use of computer animated images where if we show a face and the individual is in an fMRI and we're seeing the activity in the brain, we see that there's a lot of activity going on in this specific part of the brain, fusiform face. But if gradually through computer programming we start filling in that face with hair and that suddenly starts looking like the back of our head, then that part of the brain, fusiform face area, would be no longer active. So we know and we've confirmed that this specific area is selectively activated by human faces. The dorsal stream function for individuals who suffer from prosopagnosia may be intact. We believe this is the case because prosopagnosics may be able to recognize faces in the absence of conscious awareness. We've confirmed this when a prosopagnosic had different galvanic skin responses to familiar faces compared to unfamiliar faces, even though they reported not recognizing any of the faces. Now, what galvanic skin responses are basically relating to or involving electric current produced by chemical action. So if you go back to our physiological understanding of the brain, you know that our changes in our skin, our changes in our physiological processes are a byproduct of brain activity. And so these prosopagnosics were asked to look at different pictures in a computer. One of those pictures, however, was a loved one. Could have been their mom, could have been their wife, a child. After going through several pictures, they were asked if they recognized any of them. And they would consciously say no. And they were not being dishonest. They really had not recognized any of the faces. However, they exposed them to the same pictures again, and this time they recorded their skin responses. And while they were going through the different faces, they would ask them if they recognized them. And even when they would say, no, I do not recognize that person or that face, looking through the different galvanic skin responses, we were able to see that there was arousal in their body. A physiological change would occur when they would see a familiar face, such as their loved ones, but yet they were not aware of the fact that that was their loved one. This fascinating discovery of seeing that the individual may be able to recognize something despite not being conscious aware of this was revolutionary, as we believe that there may be a lot more unconscious stuff that's going on behind us beyond our sensation and perception. The last of the neuropsychological disorders, and the second that I'd like us to see, is what we call Tokina Topes. This is a disorder that's characterized by the inability to see movement progress in a normal, smooth fashion. If you've ever seen a video with a bad internet connection and it looks more choppy, that's what these individuals would see. Kind of like slow motion and broken up visual processes. But this is not a video, this would be real life. The rest of us that do not suffer from this in here, if we see someone walking, we'd see every single step and every single movement. We know kinetopsia can be produced and induced by high dose of certain antidepressants. Patients who consumed specific antidepressants at levels of 400 milligrams once daily at bedtime reported similar symptoms. And as we look through the effect of drugs, we could see how the drugs bring about a change in neurotransmitters. Change in neurotransmitters bring about different physiological responses. And the different physiological responses can actually make us sense the world or perceive the world differently. This particular disorder is associated with damage to the middle temporal area of the cortex. And so you can see here and appreciate that the fusiform phase area that we spoke about earlier would be inside. It would not be in the outer part of the cortex, subcortical. And then the MTV5 would be this pink area here. The MT5 appears to be responsible for perception of movement. In fact, 95% of its neurons respond to specific directions of movement and little else. Meaning if we have a specific movement, like right now you see this cursor moving, then there is activity going on in that specific area. But now that this stopped and it's static, then we would not perceive and detect any activity in this specific part. Our suspicion of the MTV5 area being responsible for it has been confirmed through several studies. And we found that through electrical stimulation of this part right here, we've been able, with human patients, to induce a visual perception of motion. Meaning even though there's no movement going on, when we stimulate this electrically, we're able to get the individual to perceive some type of response.